All right, so this is question 8 from the FRQ packet for unit 6 through 8. This came from the 2016 exam number 2. So if you want to search for the FRQ so that you can look at the scoring guideline in more detail, then that would be the one to look at. So I'm just gonna go through and start scoring. Here it gives the ideal solution. We'll look back at this if we need to. And then down below is how it's scored. So this question is scored in 4 sections. Section 1 consists of steps 1 and 2 in part A, which 1 and 2 were the hypotheses and the assumptions. So part 1 is going to be these 3 things together. And then it said part 2. Oh, not part 1. They're calling them sections. Whatever. So section. And then section 2 consists of step 3, which is going to be this one. And then section 3 consists of step 4. So that's going to be this section here. So we're going to get 3 scores from our hypothesis test, and then the 4th score is going to come from part B. Okay. So let's look at the actual scoring. Essentially correct if you have the following 3 components. Both hypotheses are stated correctly with at least one in context. So for the name of the test, it's going to say this below. This is actually a chi-square test for independence. But as far as College Board is concerned, a chi-square test for independence and a chi-square test for homogeneity are essentially the same thing. So chi-square test for independence is fine, I believe is what it says. Yes, note for component 2, it is acceptable if the test is identified as independence instead of homogeneity. Or maybe it's the wording association. I don't know, but they said it's fine. And really this is what you should have had, chi-square test for independence. Which means if I'm doing chi-square test for independence, my HO, add type, and Zudi chosen are independent. Make sure it's in context. And then add type and Zudi chosen are dependent. Again, we should be in context. According to this, at least one has to be in context. And they also would have taken, for the hypotheses, they would have taken no association and association. And they would have taken the proportion of children who would choose each snack type is the same regardless of which ad is viewed. Proportion of children who would choose each snack type differs based on which ad is viewed as my 2 possible hypotheses. So there's 3 ways you can do it. Either way, I got the credit. I got the credit for the name. The technical conditions are all checked. So all expected counts are greater than or equal to 5. So they did not take off if you didn't mention randomness, but you should have mentioned randomness. They only took off if you didn't say all expected counts are greater than or equal to 5. You had to give the expected counts. You cannot round these numbers to whole numbers. They have to have at least one number after the decimal. But you could have done more than one number after the decimal. You just cannot round to whole numbers. And you should have had randomness, but you don't have to take off if you didn't. And it should have been treatments were randomly assigned rather than children were randomly selected. So notes for component 1. So yes, we already talked about the hypotheses, chi-square test for independence, but if you did homogeneity, it would still be correct. They did not take off for randomness. You did have to report the expected counts. So you do have to have these to get credit for that check, to get that check mark. So the 3 you needed were the expected counts, chi-square test for independence, and the hypotheses. If all of those were done correctly, let's see. If you did integers, you did not get credit for the expected counts. Sorry, it's been a year since I've done this. I saw something. Make sure you don't refer to the sample. So like you don't say the children in the sample or something, anything referring to the sample and the hypotheses or the conclusion. That is a big X that will lose you credit. So like for the children in the study, like you wouldn't want to say anything like that because we're talking about the population. Hopefully my use of past tense doesn't affect that, but I think it's okay. Yeah, it probably would be better if I said that would be chosen. Just to make sure like that the past tense doesn't make it sound like it's referring to the sample. Okay, we're gonna move on. Essentially correct if we have the correct chi-square degree. Oh, I didn't talk about partially correct. Essentially correct, you needed all 4 steps, or all 3 parts, I mean, 1, 2, and 3. Both hypotheses were stated correctly. We already talked about what they were. If you had 2 of the 3, it was a partially correct. 1 of the 3 was incorrect. 0 of the 3 was incorrect. So we needed these 3 components right here. Let's move on. So we need these 3. If we have all 3 values correct, then we get essentially correct. If we're missing 1 of the 3, we get partially correct. Let's see what they got. They got 10.291. That's what I got. The p-value, they got 0.006. That's what I got. They even listed degrees for you. Okay. Well, they're saying you need degrees of freedom. I didn't see that up above, but I know degrees of freedom is 2. I don't know why that wasn't above. Maybe I just missed it. So all 3 of those to get essentially correct. 2 of the 3 is a partially correct. And they do error carried forward. I don't usually give you the error carried forward here, but if you had the wrong chi-squared value, but your p-value matched up with your chi-squared value, they would give you partially correct. And then lastly, your conclusion. Because the p-value is very small, or because the p-value is less than alpha, and then you have to state what alpha is, we reject HO. The data provides convincing statistical evidence that the proportions who would choose each snack differ based on which ad is viewed, or there is sufficient evidence to say that ad type and Zudi that would be chosen are dependent. So let's see what the actual scoring says. Essentially correct, we have a correct conclusion about the alternative hypothesis in context and provide justification based on linkage between the p-value and conclusion. Partially correct if the response provides a correct conclusion in context without justification based on linkage to a p-value. So if you left out the mathematical reason, that's what they're saying there. If you didn't have the context, that would be a partially correct. And if you didn't have the last sentence, that would be a partially correct. Note your conclusion has to be consistent with your p-value from section 2. So if you got the wrong p-value here, your conclusion is always based on what you got up above. So if you, for some reason, cannot find a p-value in a hypothesis test, make one up. And then write a conclusion consistent with that. Just make sure it makes sense. It's like pick 0.025 or 0.075, something that's a legitimate p-value, and then write a conclusion based on that. You'll get full credit for your conclusion, even if you lost credit for the calculations. And then it says, if a conclusion contains language that suggests the response refers to the sample data, the conclusion component is not correct unless the same error occurred in the statement and the hypotheses in section 1. So just to be overly cautious, I maybe should have given myself a partially correct on one of those. So this one was essentially for sure. So technically, if I made the error, I would have lost the credit up here and I would have gotten a partially correct. I'm not sure if that would be enough to get me a partially correct or if I would have gotten a full credit. Because it doesn't directly refer to the sample, but it could be because of the past tense and they didn't ask every child, it could be implied. So better to be overly cautious. Then section 4, essentially correct if the response in context concludes that ad type A had little effect and ad type B had an effect, both supported by the observed proportions or counts from the table. So here's my answer. Probably more than I needed. Based on the fact that the number who chose Choco Zooties with the Choco Zootie ad and with no ad control group was essentially the same, the ad did not make much difference. The Apple Zootie ad, however, did affect the children's choice because although more children still chose chocolate, the amount who chose Apple was much higher. Overall kids, of course, prefer chocolate. Seeing the Apple Zootie ad might influence their decision, but the Choco Zootie ad probably won't. So I said it was essentially the same, so the ad didn't make much difference. So the ad that had little effect, it was definitely in context. And ad type B had an effect. The Apple Zootie ad did affect the children's choice, both supported by the observed proportions or counts from the table. I didn't directly say what the proportions were, but I said the amount who chose Apple was higher, so I'm referring to the counts. And essentially the same, I'm again referring to the counts and the proportions. So that is an essentially correct. Ad didn't make much difference. Ad did affect. And then I talked about the amounts throughout. Let's look at theirs. When neither ad was viewed, 22 out of 25 or 88% of the children chose Choco Zooties, whereas only 12% chose Apple Zooties. When the Choco Zootie ad was viewed, 84% of the children chose Choco, which was very similar to the percentage who chose them without viewing the ad. So watching the Choco Zootie ad did not affect their snack choice very much. When the Apple Zootie ad was viewed, only 13 out of 25, or 52% of children chose Choco Zooties, and 48% chose Apple. Watching the Apple Zootie ad seemed to increase the proportion of children choosing Apple Zooties. So essentially the same as mine, just with specific numbers versus just generally talking about the numbers. Partially correct if the response correctly concludes that ad type A had little effect and ad type B had an effect, but does not provide correct numerical justification. Or if the response compares all the proportions or counts as required without correctly concluding ad effectiveness. So make sure you said which ad was effective and which was not. Or if the response correctly describes the effects of one of the ad types with correct numerical justification, but not the other. Or if the response compares all the proportions as required, but not in context. So lots of ways to get partially correct. Hopefully you got at least partially correct. Each essentially correct E counts as 1 point and a partially correct counts as half a point. So if I do P, that's a 3.5 out of 4. And they would look at this holistically when determining whether to round up or down. I'm not sure what they would do with this error because I did make it in both spots. But it's a debatable error, so they might have rounded up, they might have rounded down. I don't know. I'd rather round down just to be safe. It's pretty good though. I probably wouldn't have noticed. Well, I guess I did notice. All right, that is the end of this question. Let me know in class if you have any questions, or your teacher if you're in a different class.